So you are still on the webinar on silicon photonics with the IRT Nanoelec. We will move to the last session, which is a session on photonic applications, because with this technology, we address mainly mass market application. One of the partner of the program is ST Micro, and so with the foundries, they also need to address mass market application, and the applications will be presented by Eleonore and François. And Eleonore, I think you start. Thank you.
Good afternoon, good evening, or even good morning, depending on where you are dialing in from. So my name is Eleonore Hardy, and I work for CEA. I'm in charge of silicon photonics development, and I am very glad to have this talk today to present to you the applications addressed by silicon photonics today and the ones that will be addressed in the future. So we live in a world where everyone and everything is about to be connected and securely connected. Intelligence is being embedded everywhere, and we see with the advent of technologies such as AI, machine learning, and 5G communication, we see the big rise of cloud computing. This rise makes data centers experience an exponential increase in data traffic, and this is creating a demand for hyperscale data centers. If we look at the data generated all around the world, we see that 90% of it was created in the last 2 years alone. And the Cisco Global Cloud Index estimates that total data center traffic within a data center or exiting a data center is about to reach 20 zettabytes per year by 2021, which is huge. And as a consequence, we see pluggable optics, also known as optical transceivers, for long-haul communications and for data centers. We see those transceivers knowing a similar rise. We see the new opportunities for 100G, 200G, and now 400G data transmission. And if 100G pluggable optics is already deployed in data centers, we see that 400G is about to appear in a few months from now, because routers and switches now support 400G. Silicon photonics is part of this game for some years now. It's quite young technology, but it appeared in 2016 with Intel's first product, silicon photonics transceiver for 100G communications. And since then, Microsoft Azure Cloud Computing Platform is using Intel Silicon Photonics for I/O modules. And Microsoft feedbacks are very positive. They say it is a cost-effective way to do these deployments and gives a mechanism to scale to higher boundaries. We see in these figures from Yale from this spring, 2020, that 400G is starting to be deployed in a few months. And if we quote Cisco, who acquired Luxtera a few months ago, we see that silicon photonics portfolio from Luxtera is filling out the Cisco portfolio, and that they need such products to leverage their products for data center applications. And they mentioned that they know that integration of silicon and optics will be required in order to continue expanding the capacity of switches and routers. So this growth is driven by high volume adoption of high data rates by big cloud service operators, but also by high volume adoption by telecom operators, which have also increased their investment into the 5G networks. And owing to technological advancements, we see an increasing adoption of silicon photonics closer to the chip. So here you see roadmaps from Cisco, Luxtera, and Intel. And in both cases, it is clearly announced that photonics will get closer to the ASIC. So to address those challenges, those new challenges in getting closer photonics to the ASIC, we have seen last year, Microsoft and Facebook launching a co-packaged optics collaboration under a joint development foundation to focus on specifications for packaged integration of photonics and network switching ASICs. And the aim of such joint collaboration is also to provide guidance to suppliers for the design and manufacturing of those components. So we see new challenges and we see new startups coming out to bring new solutions. SCINTİL company is a startup created 2 years ago in France that is preparing the silicon photonic solutions to address this increasing demand for high data rate transceivers. So SCINTİL program is associated to IRT Nanoelec. And SCINTİL's technology draws upon over 15 years of research on indium phosphide silicon lasers, silicon photonics, and 3D packaging carried out at CEA-Leti. Their unique technological solution increases energy efficiency, enables an extensive integration of active and passive optical components, while significantly reducing implementation costs. So SCINTİL is combining the best of silicon and indium phosphide, using wafer scale bonding of indium phosphide on silicon and relying on commercial silicon foundry processes. In the field of computing, we also see silicon photonics coming with innovative and performance solutions. HPE, for example, is looking at silicon photonics as a way to handle information routing, saving energy, and simplifying the path data takes to reach its destination. This could allow organizations to re-architect their data centers in a way that gets rid of switches. But they are also looking at silicon photonics for optical computing. And with photonics system on chip used as accelerators running alongside CPU. Here you see in pink a microring resonator, which will be used as an optical transistor. But that's not all in the field of optical computing. We see also field programmable photonic gate arrays coming out. And for example, we can mention HYPRONICS, a Spanish startup that is developing solutions where electronics and photonics work in synergy to exploit the best of both worlds. So HYPRONICS is looking at giving some flexibility thanks to FPGAs, and which are based on generic and reconfigurable solution. We see also neuromorphic computing coming out. We can mention Lightelligence, among others. Lightelligence is, for example, building optical chips that empower the next generation of high-performance computing, thanks to optical neural network. In principle, that could offer enhancement in computational speed and power efficiency. And last but not least, we see photonics quantum computing emerging. And we can mention, for example, the Canadian startup Xanadu, that is developing quantum photonics processors that are scalable and that will work at room temperature for extremely fast computing. So why do they use photons instead of other solutions? Because they think photons are stable and almost unaffected by random noise from heat. We see also in the field of quantum technologies that it will be essential for cybersecurity, and CEA-Leti is involved also in such developments with quantum peak, QPeak, as we like to call them. Now let's have a quick look at silicon photonics market size. Even if the COVID-19 pandemic might lead to a decrease in the sales of silicon photonics this year, a quick jump is expected next year, primarily to fulfill the pending requirements of 2020. And according to the new market research report from Markets and Markets, this silicon photonics market is projected to grow from $1 billion USD this year to $3 billion in 2025. So your estimation is a bit over with 3.9 billion USD. We will see in 5 years. But what is the most important to keep in mind is that the growing requirements for high bandwidth and high data rate transfer capabilities is a key factor that drives the growth of the silicon photonics market today. But beyond telecom, datacom, and interconnects and computing, there are a few other application areas we see emerging. We can mention in life science applications immunoassay tests, with, for example, Nanoelec in the US. So Nanoelec is making silicon chip based on photonic ring resonance technology used to perform multiple simultaneous rapid tests on a small volume of whole blood or serum. And last but not least, we see smart silicon photonic solutions emerging for sensing. And those are developments, again, in which CEA is much involved with a LiDAR-oriented program for autonomous vehicles and industrial applications. But here I will let my colleague François take over the presentation and tell us more about that.